All right, so in this example, more product rule, because that's what we're working on right now for obvious reasons. All right, so here I have these two weird, wacky looking functions. You can count on me to give you something wacky eventually, because odds are in the quote-unquote real world you will see such weird examples that might be a little bit confounding. So, as before, whenever you see radicals anytime in calculus, convert it to a fractional power. Okay? Similarly, whenever you have exponents in the denominator, you might want to bring them up to the numerator and negate them. Okay? So how do we do this? Let's simplify this, algebraically first. So we have d dx carrying this along because we have not taken any derivatives yet. We're just going to transform all of our radicals into fractional powers. So I have x to the 9.6, not g.6. I've been told that my 9s look like g's. I'll insist that they're 9s until the day I die. And then, okay, then we have 1 over x to the 1/2. Note that 5 pi, that's a constant. We'll play with that later. So we have 1 over, okay, now we have x squared to the 1/5 power, because that's what's on this second radical here. So we've basically just transformed all of our radicals into fractional powers. Now we're going to clean this up a little bit algebraically. D dx, not dx dx, d dx. So when you have a power of a power, like you do right here, how do you handle that? What you do is you multiply the exponents. So you have 9.6 divided by 3. So what does that equal to? See if you can do that off the top of your head. That would be 3.2, x to the 3.2 power. This 5 pi is just going to come along for the ride for now. We haven't done any derivatives yet, no calculus. Okay, now in this term, we have x in the denominator. We want that in the numerator because we know we're going to have to use the power rule here at some point. All right, so we're going to bring that up to the top. So we have minus x to the minus 1/2. Similar thing here. I'm going to see if I can do this in 2 steps. In 1 step. So we have x squared to the 1/5. You multiply the exponents, so you should get x to the 2/5. Sorry, 1 over x to the 2/5. But instead of that, we're just going to bring it up to the top into the numerator immediately. So instead of having 1 over x to the 2/5, we're going to just negate the exponent and bring it up to the top. Just like that. All in 1 step. Perfectly fine thing to do. All right. Now, this thing is amenable to using the power rule when the time comes. But now we need to use the product rule. Product rule says, hey, if we have a product of 2 functions, you derive the first, leave the second alone, plus leave the first alone, derive the second. So that's what we're going to do here. Derive the first. So this gives you 3.2 x to the 2.2, subtracting 1 from the exponent, okay? Now what do we do about this 5 pi? It's kind of weird looking. I did tell you I was going to throw something weird at you. This is it. What is 5 pi? Is it a number? Is it a variable? Is just a Greek letter something that is you just do unknown things to it? Nah, it's just a number. Pi is 3.14159.265 blah la 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 la, right? And you have 5 times that number. Whenever you have a number and you're trying to derive it, it's 0. So 5 pi, the derivative of that, is 0. So we don't really need to add anything here. Okay? Now we just copy paste the second one. Like that. And then we copy paste the first one. So we have x to the 3.2 plus 5 pi. As weird as that is. Oh my gosh, my screen's moving. And now we derive the second one. So we bring this negative exponent down in front. So you get minus 1/2 x to the minus 3/2. Because you subtract 1 from the exponent. Do the same thing with this guy as well. So when you bring that minus 2/5 down in front with that negative sign, the negative and the negative cancel each other. So you have plus 2/5 x to the minus 7/5. because you're subtracting 5/5. Okay? With that, you are done. There's really nothing else to simplify. We skipped a couple algebraic steps just to get to the answer quicker. If you are able to do that, do it always. Okay? Save yourself some work, save yourself some writing, and save yourself some ink. So with that, we are done with this example.